Assalamualaikum, my name is Mohd Sufi Huzaimi bin Fauzi. I will present about my research topic on bleaching of XYLANASE-TREATED bamboo fiber with ECO-ENZYME assisted power ultrasonic under my supervisor TS Dr. Nasrul Fikri Benchet Park. As you can see here, this is my poster for this project, which are content abstract, introduction, literature review, methodology, result and discussion, conclusion and references. Now I will explain about abstract for this project. This study ventured to determine the effectiveness of ECO-ENZYME bleaching treatment towards XYLANASE-treated bamboo fiber with the assistance of power ultrasonic, since the conventional bleaching treatment produces toxic effluent which will affect the human health. This study aims to synthesize bamboo fiber from Schizotecium grande, 9 type of bamboo via bamboo fiber extraction machine, determine ECO-ENZYME bleaching treatment towards XYLANASE-treated bamboo fiber assisted power ultrasonic at different pre-treatment condition temperature, which is 40 degrees Celsius, 60 degrees Celsius and 80 degrees Celsius, and processing time 60 minutes, 90 minutes and 120 minutes, and analyze tensile strength via Instron 50 kN Blue Hill Universal Testing Machine, and brightness of bleaching treated bamboo fiber via Hunterlab calorimeter. The result revealed that soft Schizotecium grande fiber were easily produced via bamboo fiber extraction machine. Tensile strength shows an increasing trend with the highest value of 553.44 MPa for XYLANASE-treated bamboo fiber at 80 degrees Celsius for 60 minutes. Bamboo fiber treated with ECO-ENZYME shows decreasing trend with the highest tensile strength value of 400.66 MPa at 35 degrees Celsius for 60 minutes. The brightness of XYLANASE-treated bamboo fiber with low concentration ECO-ENZYME having highest value of 73.66 compared to higher concentration ECO-ENZYME treated bamboo fiber, which is 74.46, suspected due to the cavitation effect produced by ultrasonic that increase the diffusivity and mass transfer rate of XYLANASE and ECO-ENZYME into the fiber. This finding can be set as a benchmark of an effective method to bleach bamboo fiber assisted power ultrasonic and XYLANASE-ENZYME instead of using hydrogen peroxide that affected the environment and human being. In the process of effective dyeing for all natural fibers, it must reduce or eliminate the yellowness of the fiber. Hot alkaline hydrogen peroxide is one of the oxidative bleaching, which is the most popular method used in the bleaching the cellulosic fibers. Nonetheless, significant fiber rupture will be resulted from this chemical bleaching method. This chemical bleaching method will produce huge amount of toxic and hazardous pollutant towards environment, which goes to the soil and water bodies as effluent. The effective method for biobleaching is the removal of lignin and hemicellulose present in the wood. Pre-XYLANASE enzymes are usually used as pre-treatment for bleaching to enhance the effect of bleaching using chemical bleaching agent to minimize the release of chemicals. In a research, XYLANASE enzyme can oxidize lignin depending on enzyme concentration, pH, temperature, and time to brighten the pulp. ECO-ENZYME is an enzyme from fruit and vegetable waste which can act as cleaning agent. Antifungal, antibacterial, insecticidal, and cleaning agent are some of the functions that ECO-ENZYME perform. Its use can aid in the reduction of organic waste, the reduction of the greenhouse gas emission, and reduction of landfill garbage. The application of ultrasonic energy will lowering the time process, energy, chemicals use, and improving quality of product. The ultrasonic frequency range is higher than 16 kHz, which will perform heat transfer in liquids, and the ultrasound-induced cavitation will generate bubbles for cleaning purpose. Morphological changes in fiber will be produced by ultrasonification to increase flexibility and enhance the fiber bonding in the process of paper formation and efficient bleaching of pulp. Bamboo is largely composed of cellulose, hemicellulose and lignin, with cellulose accounting for around 60% of the total and lignin accounting for around 32%. Based on a research, bamboo fiber contains lots of lignin and hemicellulose which bind to the bamboo fiber closely without space. Bleaching process having purpose of eliminating any residual lignin that may have remained in the pulp after the pulping process and to advance the pulp brightness to a desirable level. Chemical used in the bleaching produce a variety of toxic products such as organic and inorganic salt, chloroform, dioxin, fluorine, and organochlorine compound, all of which are harmful to the environment. In craft pulp bleaching, these enzymes are used commercially. XYLANASE enzymes are usually used as pre-bleaching before the addition of chemical bleaching agent. This is because XYLANASE will enhance the efficiency of chemical bleaching agent rather than removing directly the lignin. This enzyme target the xylene network which surround and trap the remaining lignin particle rather than the lignin-based chromophores. ECO-ENZYME is a kind of vinegar made at home by fermenting fresh kitchen waste such as fruit and vegetable peels, with sugar and water as a substrate. Bioenzymes are versatile natural cleansers that may efficiently replace harsh chemicals in our homes such as bleach, phenol, and other chemical treatment. ECO-enzymes serve as an antifungal, antibacterial, anticidal, and cleaning agent, among other things. In bio-bleaching industries, ultrasonic energy can be used to intensify enzymatic treatment of natural fiber, which will enhancing the enzyme molecule transportation to the surface of fiber. Cavitation of bamboo fiber in ultrasonic is called heterogeneous cavitation. The mechanical consequences of cavitation are primarily responsible for cavitational activation in heterogeneous system. The cavitation bubble collapsing causes major structural and mechanical defect in the heterogeneous solid and liquid system. The surface collapse causes an asymmetrical inrush of fluid to fill the void, resulting in a liquid jet directed at the surface. Due to this effect, ultrasonic is used to clean solid surface, which is comparable to high pressure, high velocity liquid jet. By disrupting of the boundary layers and dislodging the material occupying the inactive site, the solid catalyst will be activated by this jet and accelerate mass transfer to the bamboo fiber surface. For the methodology part, there have 4 main categories of experiment, which are preparation of bamboo fiber sample, pre-treatment of bamboo fiber with XYLANASE enzyme assisted power ultrasonic, bleaching of bamboo fiber using ECO-ENZYME assisted power ultrasonic, and measurement and analysis part. The bamboo strip was soaked in tap water for 5 days. The bamboo fiber was then washed with tap water to remove dirt from the strip. After that, the washed strip was segregated based on its thickness. The allowed thickness of the strip should be 0.2 until 0.3 cm before entering the bamboo fiber extraction machine. The bamboo strip were thinned using machete and was entered into the machine. The fiber produced were combed using large gap comb and small gap comb to get soft fibers for the treatment. A strip with 3 until 5 grams of bamboo fiber was immersed with 1000 IU per gram of XYLANASE enzyme at different temperature, 40, 60, and 80 degrees Celsius, and the bath was sonicated for different time, 60, 90, 120 minutes, as using sonic power at 180 watt. The frequency of the ultrasonic was set up to 60 kHz. Finally, the bamboo fiber sample were washed with distilled water for multiple times prior being air dried until constant weight was obtained. The treatment of bamboo fiber starts with immersion in a bath with 50 ml of ECO-enzyme at a constant temperature of 40 degrees Celsius. The bath was sonicated for 2 hours using power ultrasonic at 300 watt. The frequency of the power ultrasonic was set up to 60 kHz. Finally, the fiber sample were washed with distilled water for multiple times prior being air dried until constant weight was obtained. For tensile strength testing, according to ASTM, at room temperature 25 degrees Celsius, the tensile strength was carried out for controlled and XYLANASE-treated bamboo fiber with a relatively humidity of 55% by using an Instron 50 kN Blue Hill universal testing machine. The strain rate was set up at 0.48 mm per minute. The brightness test is conducted via Hunter Lab mini-scan colorimeter used for measuring the reflected color of sample. Hunter Lab is color scale based on the opponent color theory, which having a wavelength range of 400 until 700 nm. The colorimeter was standardized by reflecting the colorimeter light through black tile and white tile. The bamboo fiber was ensured to have no gap between the fiber in order to analyze its brightness using colorimeter. The bleaching treatment of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic showing an increasing trend towards processing time, while for bleaching treatment with ECO-ENZYME showing a decreasing trend towards temperature and processing time. For sample 1 until 3 in bleaching treatment of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic, the tensile strength is increasing gradually with process time. XYLANASE is not really active at low temperature, thus need a longer process time assisted ultrasonication that enhance the enzyme molecule transportation to the surface of fiber. On research, the XYLANASE-treated bamboo fiber will increase the tensile strength of the fiber. By the assisted of power ultrasonic, it will increase the accessibility of XYLANASE onto fibers, and also fabrication will accelerate via cavitation effect. The use of ultrasonic also have been studied can enhance the tensile strength, density of sheet, and properties of brightness of fiber. Sample 7 until 9 showing decreasing trend of tensile strength because the bamboo fiber is exposed to high temperature for a long period of time, which lowering the valence bond of the fiber. Based on research, at low temperature, the valence bond of gum and celluloses combine steadily, resulting in a greater overall strength. the increasing of temperature of pre-treatment and bleaching process making the strength of the fiber change from higher to lower. Increasing temperature causing the valence bond become weak, consequently decreasing the fiber strength. Nevertheless, fabrication of fibers is improved with the XYLANASE treatment assisted ultrasonic. Ultrasonication boosted treatment of XYLANASE in improving the bamboo fiber mechanical properties. In liquid medium, the formation and rapid bubbles collapse is called cavitation. The collapsing between bubbles will generate higher temperature and pressure condition capable of causing chemical and physical changes. Based on research, the bubble collapsing will increase the temperature of solvent. Therefore, the trend shows decreasing tensile strength because the enzyme is started to degrade at 80 degrees Celsius, making the enzyme less effective to the bamboo fiber. In bleaching treatment with ECO-ENZYME, the tensile strength of the fiber is decreasing because there is an increment temperature and bleaching time which affected its strength. As the heat temperature increased, the tensile and impact strength increased, while the tensile and impact strength declined, which resulted in a reduced interaction between the molecules. As a result, when the heat treatment temperature exceeded 50 minutes, the tensile strength fell. In bleaching treatment of XYLANASE-TREATED with ECO-ENZYME assisted power ultrasonic having a better tensile strength of 553.44 MPa compared to bleaching treatment with only ECO-ENZYME of 400.66 MPa. This shows that XYLANASE enzyme can enhance the tensile strength of bamboo fiber effectively and does not affect by ECO-ENZYME. The trend of the graph in bleaching treatment of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic shows the brightness value is increasing gradually towards bleaching time and temperature of pre-treatment, where bleaching treatment with ECO-ENZYME having increasing trend earlier and decreasing trend after the towards temperature and of processing time. The ECO-ENZYME bleaching process of XYLANASE-treated bamboo fiber with power ultrasonic having constant temperature of 40 degrees Celsius, bleaching time for 2 hours and concentration ECO-ENZYME at 0.0125 volume per volume. The method is started with the control sample where it acts as a reference to compare bleached and unbleached bamboo fiber. In contrast, the brightness of bamboo fiber is improving when there has XYLANASE enzyme pre-treatment compared to non-pre-treatment bleaching process. Bleaching treatment condition of 50 degrees Celsius and 60 minutes with ECO-ENZYME have the highest value of brightness, which is 74.46. The highest brightness value for XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic is 73.66. There is a small difference value since the XYLANASE-treated bamboo fiber only use 40 degrees Celsius, where the optimum temperature for the ECO-ENZYME is 35 until 50 degrees Celsius. The treatment of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic are using low concentration of ECO-ENZYME, hence showing little bit lowest brightness value. At 35 degrees Celsius, the enzyme activity began to increase to temperature of 50 degrees Celsius, and the enzyme is started to denature when the temperature is higher 50 degrees Celsius with longer bleaching time because of long exposure to heat. The XYLANASE enzyme oxidize lignin and produce colorless pulp, which gives the fiber its brightness. When XYLANASE is employed as a pre-treatment agent, it removes xylene from the fiber surface, which is then deposited on the fiber. Xylene content on the fiber surface is drastically decreased after enzyme treatment, which increase surface permeability, allowing bleaching agent better access to lignin and so increasing the effectiveness of the bleaching sequence. Ultrasonication also added the bleaching process by ECO-ENZYME. Cavitation bubbles will generate shock wave lead to collapsing of bubbles with the fiber surface, creating a perfect mechanism of stirring for reaction of enzyme to place at the layer of liquid at the solid liquid interface. Sonication can significantly boost the bulky enzyme transportation toward the fiber surface by the agitation of this liquid border layer, which resulting in an improvement on the overall reaction rate. Therefore, XYLANASE-treated bleaching bamboo fiber with ECO-ENZYME giving higher brightness even at low temperature, which can reduce the energy consumption of the process. In conclusion, this study was conducted with intention to bleach the bamboo fiber with natural bleaching agent of ECO-ENZYME with XYLANASE pre-treatment and assisted power ultrasonic. The bleaching process of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic are in constant temperature, processing time and enzyme concentration but different condition of pre-treatment. The bamboo fiber was successfully bleached via the treatment of XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic. According to the result obtained, XYLANASE-treated bamboo fiber with ECO-ENZYME assisted power ultrasonic give the best tensile strength of 553.44 MPa with brightness of 72.25 at 80 degrees Celsius for 60 minutes. Nevertheless, the highest brightness obtained is 73.66 with low tensile strength of 173.54 MPa at temperature of 80 degrees Celsius for 120 minutes with low concentration of ECO-ENZYME in compared to treatment with only ECO-ENZYME. The best bleaching treatment condition was at pre-treatment temperature of 80 degrees Celsius for 60 minutes regarding to its best tensile strength, which is 553.44 MPa and brightness value 72.25. There are some recommendations provided with intent to improve future research aspect and development in bio-bleaching of bamboo fiber, which are: it is recommended that the research on bleaching on XYLANASE-TREATED bamboo fiber with ECO-ENZYME be expanded to treat other type of fiber or pulp for paper and pulp industry, and in order to compare for the best performance in terms of brightness, the concentration of ECO-ENZYME may be increased more than 0.0125 volume per volume. Here are some of my references as a guide for my research. Here is my Gantt chart for my FYP2 for this semester. So that's all for my presentation. So thank you.